students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will extend our discussion on the EMF of cell calculation using Nernst Equation. So before going to the problems or the numerical solved problems, we will see what is Nernst equation. We'll have a glance on it. So for any single electrode reduction reaction, it is like, for example, metal ion is taking up electrons and forming metal. So this is a simple reaction that is going on in any this cell. So in that we will be applying this Nernst equation. This is nothing but Nernst equation. So it consists of EMF of the cell, standard EMF of the cell, and R is the gas constant, T is the temperature, N is the number of electrons involved. N is number of electrons involved in the reaction, and F is the Faraday, that is the constant that we are applying, and then M is the product. So product concentration of product concentration divided by reactant concentration or activity. So here the product is nothing but the metal that is forming. So concentration of metal divided by metal ion and the electrons taken to the power of N, because here it is N number of electrons that are involved. So if, for example, the electrons or the concentration of electrons or the metal is solid, then it is taken as unity. So then what happens when it is unity? Why? Because here the product is 1. I mean the concentration is 1. So the metal that is forming having the concentration of 1. So we are taking it as unity. This is solid because the metal that is depositing on the electrode. So it is solid. Whenever it is unity, it is taken as 1, and therefore it becomes 1 in the numerator and the metal ions remains same. So in that case, at 25 degrees centigrade is like standard conditions. What happens? We will substitute this rate, gas constant, temperature values and the Faraday constant in coulombs, and we get a value of 0.0591 divided by N is again number of electrons that are involving in that reaction, taken to log 1 by metal ion concentration. So this is the Nernst equation that we have to apply whenever they are asking it 25 degrees centigrade or standard conditions. When there is no mention about temperature, it means it is at 25 degrees centigrade. The most advantage, what is the advantage of using this Nernst equation? Advantage is we can calculate EMF of the cell at non-standard conditions. What are non-standard conditions? When the temperature is varying, then concentration is varying, concentration of solution is varying. So at different concentrations and different temperatures, we can calculate the EMF of that particular cell. So that is the most advantage of this particular Nernst equation given by scientist Nernst. So let us move to the examples like the numerical problems. So here they have given in a cell. So there is a cell, a silver rod is placed in silver nitrate. So we have silver nitrate here, AgNO3, and a silver rod is placed. Ag rod is placed. What is the molarity? Like concentration 0.1 molar. 0.1 molar concentration is the solution, and another silver rod is placed in 0.01 molar silver nitrate. So in another beaker we have 0.01 molar silver nitrate with a silver rod. So this is the cell we have, and at room temperature is nothing but 25 degrees centigrade, and calculate the EMF. So we have to calculate the EMF. Now if we observe, they have not given the single electrode potentials here. It means we have to go to Nernst equation. Why? Because there are no single electrode potentials given to use the simple formula E cathode minus E anode. So now we have to apply Nernst equation. Why? Here they are giving the concentration. They have already given the concentration of that particular solutions. So different concentrations are given and the temperature is mentioned here like room temperature. So accordingly we have to apply the formula. So here we have a reaction. Here we have the reaction. And then we will be applying the activity of product divided by activity of reactant. So here we are taking EMF of the cell is equal to standard EMF of the cell minus 2.303 RT by NF into log activity of products by activity of reactant. So what is the product and reactant here? The when we take the reaction, zinc ions is becoming zinc 2 plus ions and the Ag 2 plus ions are reducing to Ag. So here the product is like the solid state is going to aqueous state and the aqueous ions Ag 2 plus ions is converting to solid state. S is nothing but the solid state. So this is the product, the concentration of product and the concentration of reactant is taken. So if we apply this gas constant and the temperature is at standard temperature. So we have seen already at standard temperature like room temperature, we will be applying this formula wherein 0.0591 by 2. Why 2? Because 2 electrons are involving. There is change in the electron oxidation state with 2 electrons. So into log product concentration by reactant concentration. So like that we will be applying, we will be taking the values and we will substitute the values here. Now if you see this, it is like standard E cell, E0 cell is given like 1.56 volt and after substituting here N is 2, number of electrons is equal to 2 and log 0.01 by 0.1 square. So here there is 2, the concentration is 2, so therefore we are squaring that concentration with the 2 and after recalculation we get minus 1.56 volt minus 0.0591 by 2 into log 1. So after recalculation, we get 1.56. Whenever there is positive value, we are getting positive EMF. What does it indicate? It indicates the reaction. We can predict the reaction. Spontaneity. It means the reaction will take place and it is feasible. It is spontaneous reaction and it will take place. So next one is calculate non-standard cell potential at 298 Kelvin. They are saying it non-standard cell potential. It means the conditions are not standard. But they have also mentioned that temperature is 298 Kelvin. It means 25 degrees only. But what are the non-standard conditions are there here? Concentrations. The concentrations are varying. So concentrations are varying, therefore they have also given the E0 cell or the standard EMF of that particular cell. So now calculate the non-standard cell potential at 298 Kelvin when the zinc ion is, the concentration is 2 molar. 2 molar is the zinc ions that are present in one cell and aluminium ions are having 0.5 molar. So then the reaction goes on like this. The zinc ions plus the aluminium that converts, this is reduction is taking place and aluminium ion oxidation, increase in the oxidation state. So 0 to plus 3 state is taking place. Now we will apply the formula Nernst equation. E0 is equal to E0 cell minus 2.303 RT by NF into log Q. Q is reaction coefficient. So it is nothing but the concentration of products by concentration of reactant. So now we will calculate the same thing, reaction coefficient. What is the product here? Aluminium ions is the product. So apply the same like the molarity or the concentration of aluminium ions that are present. So 0.5 squaring and 2.0, that is zinc ions that are present. Cube it with 3. Why? Because here we are having 3, so we are cubing the concentration of zinc ions and squaring the aluminium ions concentration because 2 is present here for balancing the reaction. So we will get the Q value 0.3125. So substitute the same thing in Q. like E naught is equal to 0.9. It is given in the question, 0.90 volt minus 0.0591 by 6. How the 6? 3 plus 2. 3 into 2. So 6 electrons are involved. 6 electrons, N is equal to 6 electrons are involved. So we are taking it as 6 into log 0.3215. So after substituting and calculation, we get 0.910 volt. So positive EMF value, spontaneous reaction, and it is feasible. It means this cell will work. It means it can convert the chemical energy into electrical energy. The cell can work for converting chemical energy into electrical energy. What is the chemical energy here? The metal salts that are dissolved in the solvent is nothing but the chemicals that are present. This chemical energy, chemical reactions can convert into electrical energy and produce electricity. So next is the calculate the EMF of the following cell at 298 Kelvin. Which is nothing but 25 degrees centigrade. So standard temperature. So given that, they have given the equation or the reaction that is taking place. Fe plus 2 ions plus chromium is converting to Fe and chromate ions, Cr3 plus ions. What is happening here? This is oxidation. Oxidation is taking place. Here reduction is taking place. And given E naught C3 plus to Cr is equal to minus 0.74 volt and Fe2 plus to Fe is minus 0.44 volt. Now we have to observe here they have given concentrations of the solutions. And also they gave electrode potentials or the reduction potentials are also given. So if we see here, there is no E naught cell. E naught cell is not given. So we have to calculate this. For calculating that, we have to utilize these reduction potentials. So now we will see the formula. Nernst equation, E naught is equal to E naught cell minus 2.303 RT by NF into log Q. Q is reaction coefficient. So here we have to find out, we have Q we can find out from the molarities that are present. E naught cell we can find out from the reduction potentials that are available. So now we will find out the Q. So the product is chromium, trivalent chromium that is forming Cr3 plus 2 times squaring 2 because of 2 present here by Fe plus 2 ferrous ions, cubing it because we have 3 moles of iron ions that are involving in the reaction. So product by reactant is equal to 0.01. From this 0.01 square it and 0.1 cube it and we get 1 by 10. We will substitute the same thing in this equation. Now it's time for us to calculate even E naught cell. So for calculating E naught cell, we will substitute cathode minus anode. Cathode minus anode. So minus 0.44. So minus 0.44. Why? Because this is reduction is taking place. So oxidation at anode, reduction at cathode. So this is cathode, and this is anode. So substitute in the same way. Cathode, what is the cathode value? Minus 0.44 minus of minus 0.74. So this we have to substitute minus 0.0591. Why we are taking 0.0591? Because the temperature is 298 Kelvin. It is at 25 degrees centigrade. So we are considering this formula. 0.0591 by 6. Number of electrons involved is 6. 3 into 2 is 6 electrons are involving and log Q value is 1 by 10. Q value is 1 by 10. So we get, like after calculation, we get 0.3 volt. Why we are taking plus here? Why the plus sign is here? Because the highest value is having plus sign. Minus into minus is plus. So plus 0.3 volt minus 0.00985 into log 1 minus log 10. This log 1 minus log 10. So after recalculation, we get minus 0.3 minus 0.0098 0.85. So any calculation or the numerical problems, units are very important. So it is always important to substitute the values with units so that we get ultimately the units that is left over. So we get 0.3098 volt. So the EMF that we obtained is nothing but 0.3098 volt positive. So spontaneous reaction will take place. Spontaneous reaction. So the reaction between iron and chromium will occur. So it is feasible reaction that will undergo. Whenever there is a positive sign, it indicates spontaneity of that reaction and feasibility of that particular reaction. So this is how we have to calculate E0 cell also whenever it is not given in the question from the electrode potentials that are available in the problem. So next is a test of a new reference electrode. So we have a new reference electrode present. So we have to test that reference electrode, just like calomel electrode. We have some other electrode like this. So a chemist constructs a voltaic cell consisting of a zinc Zn2 plus ions half cell and hydrogen H2 to H plus ions. So if we see here, this is the standard hydrogen electrode, SHE. Standard hydrogen electrode. So the new reference electrode is nothing but the zinc electrode. So we have to test this reference electrode under the following conditions. So the two half cells are constructed made a voltaic cell with the following conditions. What are the conditions? Zinc 2 plus ions are having a concentration of 0.01 molar. And H plus ions are the acid that is present in SHE is 2.5 molar. So the gas that we are sending in hydrogen is 0.3 atmosphere. So calculate the E cell at 25 degrees centigrade. So whenever it is giving 25 degrees centigrade, it is nothing but 298 Kelvin that we have to substitute, or we can use the formula that is available directly, having 0.0591 by N. So this is the formula we will be using. E0 is equal to E0 cell minus 2.303 RT by NF into log Q. Q is the reaction coefficient. So we have to calculate this Q from the molarities or the concentrations that are present. So what are the products? Product by reactant. What are the products that we have? Evolving gas. The gas will go out and the Zn2 plus ions are forming. So 0.3 atmospheres into 0.01 by 2.5 square. Why we are squaring? Because 2 are involved here. So therefore we are squaring the 2.5 molarity. So that will give rise to 4 into 10 power minus 4. Because it is a ratio, there is no unit for this. So 4 into 10 power minus 4. So that we will be substituting here. So why we are taking 0 here? E0 cell is 0 here. E0 cell is 0 because standard hydrogen electrode is used here. So E0 is 0 minus 0.76 for the zinc half cell that is already available in the electrochemical series. So 0.76 minus 0.059. After substituting the gas constant and temperature and Faradays in coulombs, we get 0.0591 by 2 is the number of electrons that are involved into log 4 into 10 power minus 4. And after recalculation, we get a value of E0 is equal to 0.86 volt. So positive value, positive EMF we got. So it means spontaneous reaction and feasibility. So feasible reaction. It means that using standard hydrogen electrode, we can calculate the potential of other half cell, potential of an EMF or the potential of other half cell. So next is for the cell platinum hydrogen. This is the cell notation. Cell notation is given. So that is consisting of hydrogen gas and ammonium acetate, 2 molar ammonium acetate. What is the concentration of hydrogen gas? 20 atmosphere pressure. It is set, and 2 molar of ammonium acetate is in conjunction or is in contact with 2 molar NaCl, and with the hydrogen gas in the other end also, like 0.2 atmosphere. So this is the pressure of that particular gas. So now they have also given pKa values, dissociation constant values for that particular acid and base. So acetic acid is 4.74 and ammonium hydroxide is 4.74. Calculate the EMF of that particular cell. Now this is the cell that is cell constructed, and we have to find out the EMF of that particular cell. So for example, the pH of 2 molar ammonium acetate forming. So when these both mix, there is formation of ammonium acetate. So that is, the pH is at neutral pH. So whenever the pH is neutral, the it indicates, like from the question we have to understand that both the dissociation constants are same, like 4.74 and 4.74. It means only at neutral pH it will have both the dissociation constants will be equal. So pKa is equal to pKb. So now we have to apply the formula. So we'll take E naught is equal to E naught cell minus 0.059 by N is the number of electrons into log Q is the reaction coefficient. So what is the product that is forming here? So this is nothing but, pH is nothing but negative logarithm of H plus ions. Negative logarithm of H plus ions. So we will be taking like negative logarithm of H plus ions, like 10 power minus 7 is nothing but pH value, squaring it because 2 molar is there. So squaring it and divided by 20. 20 is the hydrogen pressure that is supplied. So 0.2 by 10 power minus 7, square it, and we get 1 by 100, like 1 by 100. We'll be applying this. So this is again the 0 is taken because of SHE that we are using here. SHE 0, E naught cell. So we'll be taking 0 minus 0.0591 by 2 electrons are involved here. So 2 into log 1 by 100. So on real calculation we get 0.059 volt. So this is the EMF of that particular cell. It is positive EMF, spontaneous reaction will take place and feasible. So the reaction is feasible. Next, what is the ratio of lead 2 plus ions to tin 2 plus ions concentration required to reverse the following reaction? So there is some reaction that is going on in a cell. So the reaction must be reversed. So what should be the ratio of these ions to be present in that particular solution so that the reaction will go back or backward reaction takes place. So tin is in the solid state plus lead ions are present. So tin plus 2 ions, oxidation is taking place, and lead 0, reduction is taking place. So this is reduction and this is oxidation is taking place. Now they have also given E naught or the reduction potentials. For tin it is 0.136 and the lead it is minus 0.126 volt. So now we have to know what is the ratio of ions that are required so that this tin plus 2 ions will go back to tin ions and lead will oxidize to lead 2 plus. So now first of all we have to find out the E naught cell because E naught cell is not given in the question. So find out the E naught cell from the reduction potentials that are given. So oxidation is anode. This is anode. And reduction is the cathode. So apply the lead concentration, reduction potential here minus 0.126 plus 0.136 is equal to 0.01 volt. So this is the E naught cell of that particular cell. So E naught is equal to E naught cell minus 0.059 by N is the number of electrons into log products by reactant. So what are the products here? Product by reactant. So what is the product here? Zn tin 2 plus ions, Sn 2 plus ions by lead Pb 2 plus ions that are present. So we will substitute these accordingly. Now at equilibrium, so whenever there is a reversing of reaction, it means it has to reach some equilibrium. Only upon reaching equilibrium, the reaction will go back to the reactants. It will move towards the reactants. So at equilibrium, what happens? This will become 0. E naught cell will be, E cell will become 0. So E naught cell is 0.01, that is calculated here. 0.01 is substituted, plus 0.0591 by 2. So 2 is the number of electrons that are involving here. Oxidation, if we see 2 electrons are involved, into log lead ions by tin ions. Why we are taking? Because the reaction has to go back. So that is why we are taking lead ions by tin ions. So lead ions by tin ions, concentration is 0.458. So this is the concept. This is the ratio that is required for reversing the reaction. So till the concentration is greater than 0.458, the cell reaction exists and will be reversed when the concentration is less than 0.458. So this is how we have to, like, the ratio will be kept as such. The ratio that is calculated will give an understanding that until the concentration ratio is this much, the cell reaction cannot be reversed. So this is how we'll be, Nernst equation will help us in calculating or understanding the reversing of that reaction, backward reactions taking place during any of the synthesis process in the industrial applications. So we will see one of the example for the applications of Nernst equation, like equilibrium constant. So the standard electrode potentials of the half cell, silver plus to silver and ferric ions to ferrous with platinum electrode or the reference electrode are 0.7991. So Ag plus to Ag is equal to 0.7991 volt. Okay, then Fe plus 3 to Fe 2 plus is equal to 0.771 volt. 0.771 volt. Calculate the equilibrium constant of the reaction. So what they have given now, reduction potentials are given here. So the standard electrode potentials are given. We have to calculate the equilibrium constant K. So calculating for this, we have a formula. So we will be discussing. Now we have to know what is cathode and what is anode here. So silver ions is converting to Ag plus ions. So oxidation is taking place. Fe plus 3 is converting to Fe plus 2. So reduction is taking place. So need not worry about plus 3 plus 2. Like, it is not going to zero state. It means it is not depositing as a metal, but still reduction is taking place from plus 3 state to plus 2 state. So still it is a reduction reaction going on. So reduction reaction. So the cell formed is Ag to Ag plus and Fe3 to Fe2 plus with the reference electrode of platinum. So at anode, Ag to Ag plus and we have electron involving, and at cathode, Fe3 plus to Fe and we have plus 2 ions that are present in the solution. So the overall reaction will be Ag plus Fe3 plus will give rise to Fe2 plus Ag plus. So this is the overall reaction that is taking place in that particular cell. So now we will calculate E naught cell. EMF of that cell is nothing but cathode minus anode. So 0.771 minus 0.7991. So that will give rise to minus 0.0281. So minus 0.0281 is the E naught cell of that particular cell. So at equilibrium, what happens? We will be taking the activity of that particular products and the reactants. So E naught is equal to E naught cell minus RT by NF into ln activity of product by activity of reactant. So on substitution, since the activity of solid is always taken as 1 and is equal to 1, and equilibrium, and at equilibrium what happens? This is like Ag activity of Ag plus activity of Fe plus 2 by activity of Fe plus 3. So this is the reactant. So we will substitute here. So 0.0591 by n is the number of electrons involving. So into log k equilibrium, and this will come here, and we will substitute that 0.0281 into 1 electron is involving by divided by 0.0591 is coming in the denominator, and we get this is a value 0.4751. On logging we get 0.335. So equilibrium constant is calculated in this way. So these are some of the applications of Nernst equation, wherein we will be calculating equilibrium constant, the cell potentials, half cell potentials, and the EMF of that particular cell when the conditions are non-standard. It means when the temperature is varying or the concentration of the solutions are varying. So this is how the Nernst equation is helping us in calculating the conditions of that particular solution, so that we can apply or improve our process during any chemical methodology, so that we can improve the process and get output easily. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.